All right, welcome to section 2.5, infinite limits. You see I've got the calculator handy, so it makes me think we're going to be using it. All right, the objectives in this section are to take a look at the idea of infinite limits from a left-hand and a right-hand approach, and then to use that idea to take something we've done before back in your college algebra class, that is the idea of vertical asymptotes, and sketch some of them. All right, we're going to start out with a pretty straightforward concept here. Consider the function f of x equals 3 divided by x minus 2, that quantity squared. Now, if you remember your college algebra, you would say that this function is going to have a vertical asymptote at 2 because if we put a 2 in for x, we're going to get a 0 in our denominator. So let's take a look at how calculus would describe that same behavior. So what we're going to do is we're going to take a look at the limit of the function 3 divided by x minus 2. As x approaches 2. Now, remember from last section, from section 2.4, that the limit of a function is really found by taking the limit of f of x as x approaches 2 from the left, and then also finding the limit of f of x as x approaches 2 from the right. And if we think back, this right here, numerically analyzing this graph from the left, is that left-hand limit, and this right here is that right-hand limit. So what we're going to do is we're going to find those one-sided limits to take a look at the limit of this function. Now I've got my calculator over here. I'm going to go ahead and put this function in. Let's see, it is the fraction 3 divided by the quantity x minus 2 squared. And I'm going to go to my table. I'm going to delete out these values. I don't need them. I hate when it does that. I try to delete too fast and it... Okay. And I'm going to plug in those x values, 1.9, 1.99, 1.999, and we're going to see what happens. And it looks like we get 300. And then, is that 30,000? And then 3 times 10 to the 6, because that e right there, that's a scientific notation, or 3 million. So it appears that as we approach 2 from the left, the f of x, the y values, just keep getting bigger and bigger and bigger. Let's do the same thing from the right. So 2.1, 2.01, 2.001. I get the same values. This is also 300. This is 30,000. And this is 3 million. So what do we think that this is going to approach? Well, from the left, it keeps getting bigger and bigger and bigger and bigger. So from the left, it keeps getting bigger and bigger and bigger and bigger. From the right, it keeps getting bigger and bigger and bigger and bigger. So what do we call bigger and bigger and bigger and bigger? Infinity. Now, if you think back to college algebra, you would have come down here and said, well, right here, at x equals 2, we have a vertical asymptote, and the graph of this thing would look like this. Right? So what we're attempting to do in this section is take something that we already kind of know about, that is vertical asymptotes, and apply a calculus definition to them. Right? So basically what we're saying here is the behavior is a limit in which f of x increases or decreases without bound as x approaches c, and we call this an infinite limit. We also will sometimes call this a limit of infinity. Okay? Now, this is the rigorous calculus epsilon delta kind of definition that says, let f be a function that is defined at every real number on some open interval except c. Then the statement that the function f of x as x approaches c is equal to infinity means that for each m greater than 0, there exists a delta greater than 0 such that f of x is greater than m whenever x minus c is between 0 and delta. Similarly, the statement f of x equal, or limit of f of x per c is a negative infinity means that there's some other number. So what is all this trying to say? What is all of this attempting to say? Well, it's trying to say this. What does it mean that a graph keeps getting bigger and bigger and bigger on both sides of that vertical asymptote? What does bigger and bigger and bigger mean? Well, if you pick some big number m, 1,000, 10,000, 100,000, 1,000,000, all you have to do is get really close to c, and those y values will be bigger than m. How close? This is that delta close business, right? So this is going to be x minus c, the absolute value, is less than delta. And as long as it's bigger than 0, not equal to 0, because if it's equal to 0, the reason we stick this side on there is if that absolute value is equal to 0, then x would be equal to c, and x can't be c. It has to be bigger than 0, so it has to be a little bit away from c, right? If you move this value m up and put m up here, there's still going to be a delta that works. It's just going to be a smaller delta. You'll have to get closer. And so a vertical asymptote simply means that when you get close to c, the graph gets bigger and bigger and bigger and bigger, right? Now, this part down here about a negative infinity just means if we flip that graph upside down, that both sides of the graph, as it approaches that vertical asymptote, instead of going up to positive infinity, go down to negative infinity, right? But what's going to happen if we change our graph and we make a g of x equals 3 divided by x minus 2? What if we just go over here and delete this exponent? Now what's going to happen? So if I go to my table and I do 1.9, 1.99, 1.999. Now coming in from the left, I'm at negative 30, negative 300, negative 3,000. Looks like it's going down. How about 2.1, 2.01, 2.001? Coming in from the right, though, what's happening? Well, this side it's going down, this side it's going up, so what's going to be the limit? Well, we are going to say that the limit does not exist. And why are we going to say does not exist this time? Well, we only say that the limit is equal to infinity or negative infinity if both sides go to the same direction. So here we've got this going on. There's a vertical asymptote at x equals 2. From the left, it was going down. From the right, it's going up. And so while we do have a vertical asymptote, we don't have a limit of infinity or negative infinity because both sides aren't going to the same place. Now we can say this. We can say that the limit of g of x as x approaches 2 from the left is negative infinity. And we can say that the limit of g of x as x approaches 2 from the right is positive infinity. But we can't say the limit is anything other than does not exist because the definition of a limit requires that the left-hand limit match the right-hand limit. And since that's not happening here, we don't have a limit. Right. So then, what does it mean to say that you have a vertical asymptote? Well, this is the calculus of vertical asymptotes. It says that if f of x approaches infinity or negative infinity as x approaches c from the right or from the left, then that line x equals c is a vertical asymptote of the graph. So as long as you're going to infinity from one side or the other, or possibly both, you have a vertical asymptote. Right? All right. Some properties of infinite limits. I'm going to blow these up so you can take a look at them. So the if part here says if the limit of f of x is infinity and the limit of g of x is just some L, okay, so L could be 5 or 7, then what's infinity plus or minus L? What's infinity plus 5? What's infinity minus 7? Still infinity. What's infinity times L? Well, infinity times L is either positive infinity if L is a positive number, or negative infinity if L is a negative number. And then, what's L divided by infinity? So what's 5 divided by infinity? What's negative 3 divided by infinity? Well, divided by infinity means 0. Now, I'm pretty sure that every single one of these makes sense, except for the last one. The last one's the one where sometimes people struggle with it, because we're trying to figure out why that happens. So let's think about what's occurring in this bottom one. Right? The top is approaching L. And so let's say L is 5. So the top is getting close to 5. But the bottom is approaching infinity. So the bottom is getting big, bigger, and even bigger as it goes. And so if the numerator is stuck at 5 and the bottom, the denominator just keeps getting larger and larger and larger and larger, then the value of the fraction, keeps getting smaller and smaller and smaller and smaller. And what happens to a fraction as its value gets smaller and smaller and smaller and smaller? Well, we say that value of that fraction approaches 0. Right? Now, any one of these properties can be taken and rewritten for one-sided limits. Right? Or any of these properties can be rewritten so that the original function f is approaching negative infinity. All you'd have to do is just run through and change all your signs. Right. All right. So, what does calculus tell you about these? What is the limit as x approaches 1 from the left of x squared minus 3x divided by x minus 1? Direct substitution says, plug in 1, see what happens. That's going to give me 1 minus 3 divided by 1 minus 1. That's negative 2 divided by 0. I know that when I see this showing up in direct substitution, that I'm looking at a vertical asymptote. Right? And since I'm looking at a vertical asymptote, but what I'm not certain is, does that mean this graph is going up or this graph is going down? Now, I'm going to talk you through solving this analytically. And so we'll figure it out. Okay, so analytically, we would look at this and we would say that the numerator is a negative value, a negative number. The denominator, if we are approaching x, if x is approaching 1 from the left, that means we're talking about numbers like 0.9, 0.99, 0.999, which means that the value of this, while approaching 0, is always going to be a small negative number. And what is a negative number divided by a negative number? A positive infinity. Want me to run through that again? Okay. Direct substitution told me that when I evaluated this, I got negative 2 divided by 0. I know that a number over 0 means a vertical asymptote. What I need to know is this thing going up, where I would call this infinity, or is it going down, where I would call it negative infinity? And I don't know the answer to that. So what I need to do is figure it out. So I'm going to analytically look at this. For numbers approaching 1 from the left, we're talking about 0.9, 0.99, 0.999, and so on. These values are going to make my numerator into a negative number. Okay? These values are also going to make the denominator into a negative number, a really small negative number, but in that subtraction, a negative number. A negative divided by a negative is a positive, which means that from the left, this thing is going up, and so we are going to say that this has a limit of positive infinity. If you were unhappy with that, you could always use a graphical approach. Y equals the quantity x squared minus 3x divided by x minus 1. We said the vertical asymptote was at x equals 1. So there's your vertical asymptote. And from the left-hand side, where's it going? Well, left-hand side means over here, right? And as you can see, that thing is going up and up and up and up. So we're looking at a limit of infinity, right? How about this one? Okay, direct substitution. Always try that first. Negative 2 divided by 4 minus 2 minus 2. So negative 2 divided by 0. Hey, last time negative 2 divided by 0 meant positive infinity. Does it mean positive infinity this time? I don't know. Maybe. Okay. What does this mean? Well, that means we're looking at numbers slightly larger than negative 2. So let's see, negative 1.9, negative 1.99, negative 1.99, negative 1.999, and so on. Right? So the numerator is going to be a negative number. What will the denominator be? Well, when I square it, that's going to be positive. But then this is going to be a negative number, and that one's going to be a negative number. So, how can I figure this out? Well, if these two are bigger than this one, the answer is negative. If this one's bigger than these two, then the answer is positive. Hard one to see. Now, depending on how good you are with your math, you might know that when you square a number, you make it bigger than if you just multiply it by itself. But is it going to be bigger enough? Well, this might be one that actually would be just better off graphing. So let's graph it. So y equals x divided by, right? That's what it was, right? X squared plus x minus 2. X squared, squared plus x minus 2. And we're talking about at negative 2. So x equals negative 2. And we're talking about approaching from the right. So here. So where are we going? Positive infinity. So we would say that this graph has a limit of infinity. So the limit of x divided by x squared plus x plus 2 as x approaches negative 2 from the right is infinity. So my job is to figure out what's going on here. I know vertical asymptotes from college algebra. I'm trying to apply calculus to them. I want to give a limit definition. Limits either are going to go up to infinity, down to negative infinity. Right? What's going to happen here? Well, let's see. Direct substitution. 1. We're approaching negative 1 from the right. So plugging in negative 1 and trying direct substitution will be plus 6. minus 7 divided by negative 1 plus 1. That looks like 0 divided by 0 to me. Does that mean a vertical asymptote, or does that mean a hole? So I've chose this one and put this one in here to remind us that just because our denominator is 0 doesn't mean it's going to have a vertical asymptote. We have a vertical asymptote when the denominator is 0 and the numerator is not 0. If our denominator is 0 and our numerator is something else, something other than 0, then we have a vertical asymptote. 2 divided by 0, 5 divided by 0. Since this has a hole in the graph, then I'm going to go back to what I learned last section. Factor that numerator. What's this piece right here? That's the hole in the graph. Just do direct substitution on what's left, and I get negative 8. And so my limit is negative 8. How about this one? I'm always going to do what I always do. First things first, direct substitution. Plug that negative 1 in and see what happens. That's going to give me 1 minus 2 divided by 1 plus 1 minus 2, which is negative 1 divided by 0. Now I see that I'm going to have a vertical asymptote. So now I'm going to explore that vertical asymptote and see how that works out. Right? I'm a big fan of looking at graphs, so I'm going to go look at the graph of this thing. My numerator is x squared minus 2. My denominator was x squared minus x minus 2. Okay. And I'm taking the limit at, I believe it was at 1, wasn't it? Yes, at negative 1. So I'm taking the limit at x equals negative 1. All right. This was not a one-sided limit. So I have a problem because from the left, this thing is going down. From the right, this thing is going up. So the left-hand limit was negative infinity. The right-hand limit was positive infinity. So what is the limit? The limit does not exist. A limit only exists if the left-hand limit and the right-hand limit are the same. There's a whole bunch more of these. 4 more. Okay. What's going to happen here? Well, try direct substitution. 1 over 0. Plugging in the negative 1. Okay. So I'm going to go take a look at a graph to find my left-hand limit, to find my right-hand limit, and see what's going on. 1 over 2 times the quantity x plus 1. I'm just going to get rid of that whole thing now. 1 divided by 2 times that quantity, x plus 1. And where are we taking that limit? Oh yeah, negative 1. So what's the left-hand limit? Going down negative infinity. The right-hand limit? Going up positive infinity. So the left-hand limit is negative infinity. The right-hand limit is positive infinity. So what's the limit? Does not exist because left doesn't match right. How about this one? Direct substitution. 2 over 0. 2 divided by 0 tells me I've got some sort of a vertical asymptote thing going on. Again, I'm going to go take a look at the graph because that's the easiest way to see these things. Okay. I have x squared plus 1 upstairs. And what do we have downstairs? We had x squared minus 1. And we are taking a look at the limit at positive 1. Okay. looks like the left-hand side's going down, the right-hand side's going up. So my left-hand limit is going to be negative infinity. My right-hand limit is going to be positive infinity. So what's going to be the limit? Does not exist. Because the limit only exists, even vertical asymptotes, limit only exists if left hand and right hand are the same. Cotangent, as x approaches pi. I don't remember my cotangent graph, do you? So I'm going to go look at the graph over here. This is x going to be approaching pi this time. And this needs to be cotangent of x. Left going down, right going up. So the left hand limit was negative infinity. The right hand limit was positive infinity. So the limit of cotangent x as x approaches pi does not exist. Okay. All right, last one, and then we're done with section 2.5. Nothing more after this. X squared plus 2x minus 8 over x squared minus 4 as x approaches negative 2. Direct substitution. 4 minus 4 minus 8 over 4 minus 4. Negative 8 over 0. What does negative 8 over 0 mean? Vertical asymptote. I have no idea what it looks like, so I'm going to go take a look at the graph. I don't know what I just did there. X raised to the second plus 2x minus 8 divided by x squared minus 4. Yeah, well, you know I got it right. And we're taking a look at 2, I believe. Negative 2. Left side's going down. Right side's going up. Left hand limit is negative infinity. Right hand limit is positive infinity. So then what's the limit? It's a big old does not exist. Okay? All right, so this is section 2.5. In section 2.5, we're going to talk about infinite limits. Basically, we're taking something you already know, giving it a calculus name. We're taking vertical asymptotes that you studied in college algebra, and we're giving it a calculus definition. And what's the calculus definition? We are saying that if a function approaches infinity as x approaches c from the left or from the right, then that line x equals c is a vertical asymptote. So if the graph goes up, vertical asymptote. If the graph goes down, vertical asymptote. If the graph goes up, vertical asymptote. If the graph goes down, vertical asymptote. Or any pairing of two of those pieces. Right? All right, this was a long one, but it brings us to the end of section or chapter 2, which means we will have an exam over sections 2.1 through 2.5. Once you finish the homework for this, you should be good to go to take that exam.